agent platform for the enterprise, primarily financial services, healthcare, public sector. It is if you are in a position where your data is important and also you want to have full control of the whole agentic workflow, then Rasa is the right solution. And I show a little bit why. So why is it that we're here? And Cedric already shared some things, like really the spirit of this talk is why voice AI agents fail. And I want to share with you, so 4 failure modes, so situations when these models fail. And we'll see there's some overlaps with what Anne was just saying. When I was listening, I said, wow, this sounds, I see some parallels, but while she was discussing it, I'd say more from like the project organizational side. Here we look a little bit more on the implementation software engineering perspective. So you'll see what we're talking about soon. And yes, Cedric already introduced me, so I've been around for a while, really pre-Gen AI and everything. And if you want to connect, I'm always available in pretty much all social media channels. Happy to talk now, or we have also a booth for Rasa here outside. We can also show some demos and go more in depth about these voice AI agents and their failure modes. So why is it that we are saying this? It is because often, for example, when I talk to people, they ask me, oh, which model should we use for like text-to-speech or so here transcription and so on? So is there like a one that is better than the other? And I feel that often these discussions, they are not that relevant because pretty much all models, they are really, really good. And no matter which vendor you're taking, they're really state of the art. So it's almost like a matter of preferences and maybe which type of like pricing you can negotiate and other aspects. But at the same time, we can see that voice AI as a product is not really so great right now, so right? We're not seeing that many voice AI applications, and very often it's more like on the demo perspective rather than in practice. And that's because, in my argument, it is that the problem is in this orchestration. There are pieces in between these different components, like the ASR, the text-to-speech, and so on, that need to be built by us, the agent designers, the engineers behind, in order to have this fluid experience. So we'll see so here 4 of them, because as I'm saying here, the demos are this exception. And basically like what we're seeing is these 4 sub-problems. One is, for example, what happens when like the agent is stopped at mid-sentence or vice versa, so the agent stops you. Then also what happens when we have different words or utterances that can be interpreted differently by an agent. And then also what happens when we have like so too early, the conversation is too early. So the first one is that I said this thesis. We have to start thinking, voice is a very different product than text and so on. Very often we come from a perspective of saying, we already have like an assistant, a chatbot and so on. So why not we just add an additional channel? Instead of text, we'll just glue voice on top. And that's not the right way to see it. We need to see really voice as its own product and treat it differently. Because these are like 4 failure modes that we're having. And basically none of that happens when you're having just a text-based agent, text-based chatbot and so on. The first one is that having this turn taking when I am talking to the agent and when the agent is answering is much harder in practice than it looks on demos and so on. The other one is how different words can have different interpretations and therefore that can make the agent behave differently. Then, given that we have all these components glued, like the text-to-speech, the transcription and so on, we have between each of them multiple failure modes and ways how they can disagree. So what can we do there? And then finally, how do we end these conversations? How should a so happy path should look like if we do not really know when things in a conversation? So the first one, if we think about how it is in a classic so text-based chatbot application and so on, it's very easy because we get an answer, for example, with ChatGPT that asks, what do you want to know? And then you say, well, you write it down, and then you just click here like send button. Or even if you use the voice mode of ChatGPT, first you record, then you transcribe, and then you send it. But in a pure voice application, what happens is that you're talking, and for example, if we think like a banking agent, it will ask, what's your bank account number? And then we start saying the numbers, and these numbers tend to be longer, right? They're not short. So we humans tend to pause at some point, need to breathe. And here's the challenge. How does the agent know that now we finished saying our bank account number or that we're just taking a break? And I have actually, so here's some scripts, and if we have time I can maybe like show them, or we can also show it at the booth. They're also on GitHub, so in case you want to run it. But if you use modern models and also modern ASR and so on, you'll see that it's very easy for the agent to get confused. And if you have a break in between, you're saying, oh, my number is 0664, and then you pause, and then after that you say the rest, you will not see it as one single number, but as two different ones. So that's an actual problem, and that happens not only with numbers, but with many other circumstances, like emails, names, and so on. So what is it that we can do for that? Well, one way how we can, so once I see this, is that we have to differentiate between what is acoustic silence and what is semantic completion, right? So one thing is where we finish our idea communicating that, and the other one is just there's nothing more to say. And within the same time, within milliseconds, this can be the case. So how can we solve that? Well, one idea is, why not we have, in addition to like our main model that is powering this voice AI agent, a smaller model. And I've been making tests, for example, with a very small gamma model, 2 billion parameters, very small but very fast, where it can work as a classifier, where we can be asking for this given sentence, this is running on the background in parallel to like our main conversation, is asking, is this audio silent? Is it complete thought, and so on. So it's basically providing this information extra, and then it can decide, the main agent, if now we have a pause or this is really the end of a sentence. So once we have fixed that, what happens when we have tools that look like back channels? What I mean by that, it is that if we look at conversations, we have situations where the same word can have different meaning. For example, like yes. Yes can mean an affirmation, but it can just mean, yeah, like a word in between. Or even something like So I can say to basically agree or disagree, depending on my culture. Or it can also be a sign of surprise. But what happened in those cases as well? So what if the agent, for example, is asking me, is your bank account number 12345? And I say yes. Does that mean that I'm agreeing? Or I'm saying yes, but I want to know something else. This is just the beginning of a sentence, for example. And that's a challenge because as soon as the agent recognizes that this is, for example, an order, an instruction, then it will trigger other parts of the system, right? It will go ahead. And that means that not only will it confuse, but likely will provide a bad experience. It will provide a confusing experience. So what is it that we can do here? Well, again, here, one idea is, why not we try to classify that? And here as well, we can even think about simpler approaches. We don't even need to think about, let's have some LLM behind, some other model, but pretty much we can have just counting. You can start basically by counting words, and then based on like the number of words that we're counting, and also of course, this depends on the language and the culture, so it's not exactly something that we can just use for all languages and so on. Then we can decide if this is really an instruction or just a filler for a larger sentence. And then of course we can have an LLM behind. It will be more precise, but at the same time it will add some extra latency, some extra cost. Across all these suggestions that I'm having, we're also seeing some pattern here. And that's that we're adding extra latency to the whole process, right? So here we're trading a little bit, having a better experience with having a voice AI agent that is slower, right? We cannot have just our cake and eat it at the same time. There is something we have to pay here. And here we see in this third failure why it makes sense to start thinking about these other ones, because if we think about what we're saying, that we have all these different systems, right? We're saying in the user flow, for example, the user says, what's my balance? And what will happen is that we'll have a transcription, and then this will be given to the agent, and the agent will likely call some lookup account function, maybe some MCP tool, whatnot. So it'll be acting in the background. And this is already triggering this flow. But what happens if, for example, in between this process, then the user say like stop, or I don't want to know it anymore, or tell me something else, and so on, right? So we basically change the instruction in the middle of the process. Well, then somehow it needs to go back and then go back to the beginning, right? So it needs to go back and first understand that this is something that is forcing the process to not continue, while at the same time it is necessary to basically go back and decide again. And here another challenge is as well, how far do we go back again, right? So if we say, for example, like stop, do we stay in this part of like the lookup of our bank account part, or do we need to go really to the beginning of the conversation and then like offer what are the options and so on, right? So this is something where it has like a lot of nuances and a lot of like tricky parts. And what is that we can do for that? Well, one idea is why not we have a token that we're passing, like I call it like a cooperative cancellation, meaning across all these processes, instead of just passing like the transcript as it is, they're just passing basically system prompt, we're also passing an approval, we're also passing an agreement saying continue and go further. And this token is something that can be sent fairly quickly to a system, basically, and then in case that someone, so for example, calls the word stop, we can send it across our whole system, and this way we can basically like stop it and then have some extra logic, for, of course, in order to decide how we go back and so on. Okay, so, and then like here, this fourth part on saying goodbye too soon, where if we think about an agent and how they act is that we are asking questions and so on, and at some point is when is it over, when is it continue? We're fairly easy, for example, if like the agent provides the information, then the user might agree, right? It might say, all right, that makes sense. And the agent might interpret it as this is the end of the conversation. I will say, oh, okay, have a great day, and then hang up basically. And this might not be what we want, right? So it might be that later the user wants to know something more and so on. So this again, we see this other pattern where compared to like a text-based approach, here we do not really know when something starts and when something ends. And this is something where on top of that, we have the challenge of just the long horizons of the conversation that we have to remember. And if we go back to here, our little workflow, so our little flow, is that if we think about how the agentic loop works, is every time that we're saying something and we're transcribing it, we're appending it to the model, right? So we have our context window. So we're attaching new conversation, new instructions. So we're talking about a very long conversation that we're having. At some point, will start happening that the model will start forgetting things, right? So at some point, it will not anymore what's going on. And this also has as a result that because it gets lost, it doesn't have full information, then it will, for example, break. And this can happen, especially in these longer calls, but also in general when we are using a model that is a small one. And this again goes back to the point that I was saying, how we have always this trade-off between latency and the user experience. Because if we say we want to optimize for latency, and going back here to this part, if we want to optimize for latency and have this that is very snappy, this part of the agentic loop, then we'll be having a model this small. But this kind of trade-off, that this model has low capacity for the number of tokens that it can hold, it's low context window. But then if we say, hey, not the opposite, we want to have something that is very robust, can maybe like take conversations that last, I don't know, half an hour or longer, whatever it is, then that comes as a trade-off that will be a slower model. There will be some latency, and that might impact user experience. So here we're seeing how we need to decide where we want to add more latency with the benefit of having more control, but also being aware that as a result, we might have like some challenges behind in the design of our agent. So here, what is it that we could do in order to control security conversation? Well, here, what I argue, and also how Rasa is built, is let us not think about pure agentic architectures. Let's not think about just pure, like what we call like LLM wrappers, but rather let's have gates, control gates, that decide at specific points throughout the conversation, specific phase in the conversation, how it should behave at the agent. So here, basically mixing this world that we know from NLU, from the agents that were historically developed before Gen AI, and then mix it with an LLM generative AI approach. Because this way, we can, with these control gates, with these hard rules, we can decide if something really happened or not, right? It's a little bit similar to what we were saying earlier of let's have classifiers that determine where we're in the conversation or how should we react. But here we're saying let's have hard rules that are deterministic for that. So with all this, basically we're trying to say we want to have freedom where it matters in the process. We want to benefit from what Gen AI offers, that is free flow of conversation and so on, but we also want to have these harnesses. We also want to have these control parts in order to basically have a good experience, and also something where we as agent engineers, as agent designers and so on, can have full oversight of how the conversation will behave, steer it in the direction that we want. So yeah, with this we have covered these 4 failures, and if I want to recap, it's basically this turn taking, So deciding when I'm really finished with my sentence or when I'm just like taking a pause. Then all these words that can be interpreted differently, that can have some meaning, some context on another in another, then how do we handle the different blocks, the different components of our system when we have, for example, interruptions or when I change the direction of the conversation flow? And then how do we know that we are really finishing the conversation or this is something that the conversation will continue further? And as we're seeing, this is nothing to do with really like the model itself. It's really not, I would even say like Gen AI. It's more about systems engineering, so as we should see it. Because going back to the initial point that voice AI agents are a different category, different animal compared to text-based SO agents. And with voice AI, we should see them really as concurrent systems, not like turn-based ones. And that really changes how we should approach the design and the development of our voice AI agents. And that's something also we've seen at Rasa. So Rasa has been in the space of doing conversational agents for now 10 years. And it started with this very like text-based approach. It started really, so here with hardcoded rules, conversation flows, and so on. And now, especially since last year, we were working very hard towards making this voice native. And we also been through this journey of realizing we cannot just add this as a feature, but really we have to reconceive the architecture completely, because otherwise we cannot provide a good experience that really matches what the user expects in terms of like voice interaction. Basically, it's many of the things that Anne was saying earlier. So for us having also this journey, and then we have a little URL like 2026.rasa.com, where we share here some videos and some learnings, some small snippets, so you can watch on why is it that we've been working at Rasa in order to have this voice parity, in order to have voice as first-class citizen. And we're also like launching here in a course as well. So it's something where we are seeing all these failure modes for agents. And here in our GitHub repository at Rasa, we have this course, Why Agents Fail. And we're packing all these learnings, not only for these failure modes that we're seeing, but more broadly, what are like failure modes in conversational agents, how we can work against that, and how we can build our harness in order to basically have these robust models. And then also as well, we're having a social mixer, so later today, so it's 6 p.m. If you want to join, please come and join us and we can continue this conversation as well. So it's here, like the URL is Rasa-1EFJ. You can just find the Luma. And that's everything from my side. I'm sure you have many questions, so I'm happy to answer them. And if you want to know more, also, I'll be here at the booth outside.